here in this module. So first, the concept of the stress will come here first. The concept of stress. So, one arbitrary body, if you are considering here one arbitrary body, over this body, some forces acting over the body. Some force is acting over the element. It's an element, fluid element. Now, if you consider a small elemental area here, small portion. So what would be the effect of this force? So this small area, if you are considering here, the area is the dA. Over this area, the same for some stress will be acted, resistant to the forces. The stress is, if I given a force, it will be developed in the material as a stress. So the small amount of the area, this coming is the dA by dA. So F is a vector, force is a vector quantity, and area is also a vector quantity. How area is a vector quantity? Because area orientation is necessity here. Orientation of the area. So area magnitude, you know, if you consider one area, we know this magnitude if it is dA. And from the area, if you draw one normal line, it will give you the direction of this area. So area orientation of the area is also necessary. So area is a vector quantity. Now, new concept will come, traction vector. It's known as the traction vector. It is denoted in this way. I is the direction of the force, and N is the orientation of the area over which area it is acting. So this is the traction vector. Is the concept of the stress we are talking about the traction. Now this I, along x-axis, the I can be considered as a 1. So along x-axis. So T1N means the force direction along x-axis. If I is equal to 2, the T2N is the force direction along y-axis. And I is equal to 3, the force direction is along z-axis. These are the concept of the stress. So stress is the resistance to the force. It is developed inside the body. Now in this elemental area, over the elemental area, if you consider a small area dA, so over the area, what is the effect of this force? The force effect is coming in this way, dF by dA. And that is nothing but the traction vector. Now the representation of the force, how? It can be, it is as a, so what you see here, a symbolic representation of it. We are writing it as a tau ij. Tau ij. So tau ij, or better to write it tau ij. So I is can be here written. It is the area normal direction to the area. First, I. And the J direction is the along the direction of the force. Or better, you can write it down, better to write it. Some sort of places write it as a tau x1. So what is the x? This x is, that is a representation of a stress. Now we are talking about the representation of a stress. So tau x, this x is normal to the area direction. And y is the along the force direction. What does it mean? If the force direction along x-axis, the force direction is along x-axis, and normal to the area is also x-axis. So you will write it as a x-axis is along x-axis, I is equal to 1. So tau 1, 1. Tau 1. So tau 1, 1 means the first one is for the normal to the area, second one along the force direction. Similar way, the tau 2, 1. Here the 2 is the first index. The 2 is normal to the area. That means from the area, if you draw a normal line, it is along the y-axis. From the area, that means which area is covering this area? Over this area. So from the area, if you draw a normal line, it is along y-axis. So that's what it is. And the force direction is along this x-axis. So over the plane, tau 2, 1 means in this plane, the stress is acting in this way. Because it is a area normal to the area, and it is along the force. So that's why we are representing a concept of the stresses. It can be defined in this in a better version. Now here it is along the x-axis, is the y-axis, it is the z-axis. So along x-axis we are considering it's 1, along y-axis we are considering it 2, along z-axis we are considering it 3. So here we will see the representation of the stress. How many stress will be acted over the plane? So this plane, we are first considering this plane. This is the plane. So this is your this area. So this area, if you draw a normal line, from this area, it will be along x-axis. So over this area is the constant. So how many forces acting over it? One normal force, normal stress is acting. One shear stress in this direction, another shear stress in this direction. So 3 possible stress is acting here. One is the normal. So normal we can represent it as the tau. This area is 1 because normal to the area direction is along x-axis, and the force direction also along x-axis. So tau 1, 1. We are taking. What about this thing? This we can represent as the tau area. First index is the normal to the area. Normal to the area is the 1, and the direction, second index, direction to the force is 2 along the tau 1. About this force, what we are writing it, tau, the First one is the tau 1 is the same because area is the same and it is along the z-axis. Force is along the z-axis, so tau 1. So this way we are representing a tension, stress tensions. It is more general. Tension is a noun because vector having only one direction. Scalar, no direction. Vector having one direction. Tensor is the more general than the vector. Here tensor term is coming because the force direction as well as the orientation of the area is considered here. How this area is oriented? This area is oriented different way. This area is oriented different way. All area are oriented in different way. So each and every area there are different kinds of the stress will be acting. Now you see here in this area, the top area, what are the forces acting? What are the stresses acting? So one stress will be act along this. This can be represented as the tau. This is first is the 2 because if you draw the normal area, normal to the area is along y-axis, so tau 2, and force is also the 2, so tau 2. Another is a normal force. Next, another is the shear force. It can be represented as a tau. 2 is the same because same area over this, it is acting, and 3. Direction of the force is a 3. Along this way, one force is acting, which can be represented as a tau. 2 is common because the same area and force direction is the 1. So this is representation in this way. Same way in this surface, about this surface we're considering. So in this surface, one force is acting, it's a normal to the area. So this normal to the area force can be written as the tau. So area is the, if we draw the normal to the area, it is along the z-axis. So the 3, and force distance also the z-axis, tau 3. Along this way. This is the tau 3, 1. Here it will become tau 3, and force direction is a 2. Tau 3. So how many number of components is coming? In this surface, tau 1, 1, tau 1, 2, tau 1, 3. Over this surface. In this surface, tau 2, 1, tau 2, 3, tau 2. In this surface, tau 3, 1, tau 3, 2, tau 2. This way, the forces, stresses is coming here. This way, the stress is coming. So, this stress is not only depends on the force direction, it is depends on the orientation of this area. That's why the stress is not a vector quantity, the stress is more generalized, is the tensor. Better to say it's a second order tensor. So here, now you see this portion. These 3 surface, you could be able to see how the stress is acting. The similar way, if we considering this surface, that means this surface. considering this surface. So this surface now, from the surface, if you draw the normal, from the surface, if you draw the normal, it is along this. Because all normal should be outer to the system. Normal outer to the system. So it is, if same way, x, y, and z. So it's a -1 side. Opposite, minus x direction side. Area, from the area, if you draw, minus x direction side. So if stress is acting in this direction, normal stress, same direction. So the tau -1, it is not written in this way. It is better to write it this way, tau 1. So in this surface, the tau 1 is outward from the surface. In this surface, tau 1 in this direction. This is tau 1. Representation wise, I'm telling. So from this surface, the tau 1 in this direction. From this surface, the tau 1 in this direction. Outward from the surface. So this is, we are not writing. It's writing as tau 1. Same way, if the shear component, if it is acting in this way, we are writing it as here tau 1 because the area is the same 1 and direction is 2. It is not valid. It's a negative quantity because this direction is not in this way. So this is where considered. So this is tau 1. This is the tau 1. In here, in that case, it was like this way. Tau 1. So tau 1 and tau 1, the entirely two different surface is the opposite in direction. The opposite surface, it's the opposite in direction. Here, in this surface, if you're considering, it was like that tau 1,3. So here, this side is considered as the tau 1. So this surface here, this surface and opposite surface, the behavior is something different. Representation is the same. So at the area 1, we are getting the 3 components. One is the normal component, 2 shear component. At area 2, we are getting and area 3, along the 3 area, tau 3,1, 3,2. So total 9 number of components we are getting. So it can be represented as a 3 × 3 matrix. We'll see it later. So we got from the stress is a tensor, second order tensor. Vector is the first order tensor and scalar is a 0th order tensor. A vector quantity is a first order tensor and scalar is the 0th order. So vector only depends on the direction of the force. Stress depends the direction of the force as well as the orientation of the area. How the area is oriented. If the orientation of the area is changed, the stress value will be changes. So from a surface, if any normal, so stress having 2 components, you see this is the tau 1 tau 22, and tau 33. These three are normal stress components. And other than this, all other shear stress components. So if you write this thing in a order somewhere else,